All right, so this afternoon we worked the straw pipes challenge. A lot of you had a lot of great success with the octaves and the fifths, seeing how the change in the instrument affected the sound wave. Today we're going to continue looking at waves and ask this major question. What are the characteristic properties and behaviors of waves? In this screencast, we're going to look at frequency and speed of a wave, but tomorrow we can jump right in and get going with how do we affect what are waves and how can we measure them. Again, what are the characteristic properties and behaviors of waves? The important thing to remember is simply that waves transport energy. That is what waves are, whether they're mechanical or electromagnetic. They accomplish the same primary function. Remember, wavelength, this is until a wave repeats. It's really important and useful to use when calculating different aspects of a wave. You can see crest to crest, and I'm going to minimize this screen and kind of get going in motion with this simple wave simulator. All right, so we'll start moving. Sorry, maybe not. Sorry about that, real time. So wavelength, the time it takes this red point here to get top and back to top again. That's one wavelength. Here this wave is going at 100 centimeters per second. There's a frequency, which we'll look at next, of 0.3 hertz. That means we have about 0.3 frequencies pass by every second. So we'll come back to that in a few minutes. We can back up our slides. All right. Frequency is the number of wavelengths that pass by a point in a second. We hear this in sound. Higher frequencies are higher sounds. Lower frequencies are lower sounds. Remember from this afternoon, when you decrease the size of this instrument, of the straw, you got a higher sound. What we expect is smaller instruments. Think of a flute or a piccolo compared to a tuba or a baritone. Same principle applies also in light. In visible light, the frequency determines the color. Of course, here they show wavelength. Same rule applies. As frequency increases, determines what color we see. Even beyond, as frequencies increase, as we move to the left, we see, all right, here's our visible spectrum, which is only a small part of all the possible electromagnetic radiation. So frequency increases, we have ultraviolet to X-ray to gamma rays. And as we decrease frequency, go from violet, blue, green, yellow, orange, red into infrared, microwave, radio waves. And notice how as frequency increases, wavelength does the opposite. Important concept which we will return to is that's one of the major behaviors of waves. Speed of waves, especially, speed of waves for mechanical waves, in large part is determined by the medium. That is, what is it moving through? Again, we're going to kind of switch. I think I wanted. All right, this is a Slinkolab. You'll look at this later on. So we see here we have a continuous pulse of motion. And density, tension, and damping are all properties of the slinking. We can change those in here. So as we decrease the density, you can see how the wave behavior changes. How dense is the material it's traveling through. How closely packed are all the molecules. Right, tension, decrease tension. Again, how does the wave behave? Damping is how much energy is lost from molecule-to-molecule interaction. At very high damping, see how big the wave is here? It's losing all that energy before it reaches its fixed end. If you switch to free end, same thing. See how small is the amplitude at the end because it's losing energy. Again, these are things we'll have going up later on. Those different interactives you'll have a chance to work with soon. You can also say speed is equal to wavelength times frequency. But speed of waves is determined by the medium. So as wavelength increases, frequency decreases, so long as we're in the same medium. All right, I forgot to put these up, but I will post these to the class website and we'll begin working them tomorrow. And just to close out, the main question we're looking at, what are the characteristic properties and behaviors of waves? So in this video, we looked at frequency, we looked at speed. Considered briefly how light and sound are both waves and how different frequencies affect them and how we perceive them. So tomorrow we'll begin some simulations to work with waves to see more so what are their characteristic properties and behaviors of waves, with our long-term goal of seeing how do we use wave technology to transmit information both in storage and through the air as radio, cellular, what have you. All right, guys, thanks for watching, and I'll see you tomorrow for science class.